talk about electrolytes, what it means for something to be an electrolyte. Then we're going to discuss how to tell the difference between electrolytes and non-electrolytes. Okay, so by definition, an electrolyte is a substance that conducts electricity when dissolved in water. So when it's dissolved in water, that solution will conduct electricity. That's what that's saying here. But how does it conduct electricity, or I should say, why does it conduct electricity? It does that because electrolytes form ions in solution. And since those ions are in solution, that means those electrons are going to be free to flow because the ions are free to move around the solution as well. Okay? So electrolytes tend to be ionic, acids, or bases. That's how you tell what an electrolyte is, okay? Now, do you remember how ionic solutions, or ionic substances, are metals with nonmetals, generally speaking. You can have polyatomic ions in there too, don't forget about that. But examples here, we've got NaCl, we've got CaO, okay, so we've got sodium chloride, calcium oxide. It's a metal with a nonmetal, transferred electrons, those two have charges. Now, acids are anything that start with H's, okay? So we've got HCl, we've got H2SO4, okay? Bases are, that's the one I haven't talked about as much. They end in OH or hydroxide. So we've got sodium hydroxide, okay? So the reason why this one is not one I list is usually I just tell you to memorize ionic and acids because bases are actually ionic substances. So if you just remember ionic and acids, that's going to help you remember that it's an electrolyte. Now, I told you that they form ions in solution. Let's see what I mean. I'm going to actually show you what sodium chloride does when in solution. Now, if you remember our reactions unit, you're going to remember that we've done this before. We did it in our net and complete ionic equations. Okay? So we take sodium chloride, solid, and we put it in water. Okay? And you remember how it actually splits apart into its ions? So Na becomes Na plus, and it's aqueous, plus Cl minus, aqueous. Remember how we break apart the ionic substances, write their charges on the top top right corner, okay? Now, let's look at this acid here because you're going to see that acids actually do the same. And again, if you remember from the reactions unit, you're going to see that we did this before, okay? I won't put the phases of matter there. We won't worry about that, okay? Now, do you remember what happens to the two when we split it apart? It doesn't become H2. That's actually hydrogen gas. Instead, that 2 gets moved to the front. Do you remember that? 2H, and then H has a +1 charge, aqueous, plus SO4. Do you remember how polyatomic ions do not split apart themselves? We don't break apart the sulfur and the oxygen. And sulfate has a 2- charge. If you don't have that memorized, do you remember where we looked to find that? Yeah, your reference table, okay? Your reference tables are going to tell you what the charge of that is, okay? And that's aqueous, okay? So you see how acids and ionic substances actually break apart in solution, okay? Now let's talk about non-electrolytes. Non-electrolytes are all other covalent substances, and I say all other because technically acids are covalent. Acids are the only covalent substance that's actually an electrolyte, okay? So non-electrolytes are everything that left that's covalent, okay? Now, some of these are a little bit more easy. We've got CO2, we've got SO3, okay? So those are our binary covalents that we learned how to name. But I also want to tell you that there are also sugars that you would need to be aware of, like glucose, C6H12O6. But I also wanted to point out alcohol, because alcohols end in OH, but they are not bases. They're not bases. And the reason why they're not bases is because this is not actually the hydroxide polyatomic ion. For example, methanol is CH3OH, and it is an alcohol, okay? We also have ethanol, which is CH2OH. What do you see as a pattern here? Alcohols is when an OH is attached to carbon and hydrogen. That is not a base. Nope. So therefore it's a non-electrolyte, okay? I wanted to point that out because you are going to see these alcohols in your homework, on your quizzes, on your tests, and I want you to be aware of those not being electrolytes. They're actually non-electrolytes. But let me show you what sugar does in solution. We saw over here that electrolytes split apart, become ions in solution. Let's see what happens to sugar. Sugar is a solid, or glucose in this case, a specific sugar, is a solid. Does sugar dissolve in water? Yes, because we have things like Kool-Aid and sweet tea and soda. Yes, sugar does dissolve in water. Non-electrolytes, a lot of them do dissolve in water. But do they split apart into their ions? Do we split this apart into carbon, hydrogen, and oxygen ions? No. Why? Because it is covalent. So it's going to look like this. C6H12, O6, but now it's dissolved in water, aqueous. Okay? Do you see the big difference there? They both dissolve in water, but these form ions in solution, therefore conducting electricity. This still dissolves in water, but it doesn't break apart into its ions when dissolved in water. Okay? One thing I want to tell you about covalent, remember that another word for covalent is molecular. Just trying to remind you there, molecular means covalent. Okay? One last thing that I want to remind you of, this is going to bring us back to the bonding unit. Okay? Remember our very important question on the bonding unit, we are constantly asking, is it ionic or covalent? Okay, so I want you to ask that question as you're trying to figure out if it's an electrolyte or not. If it's ionic, it's an electrolyte. If it's covalent, with the one exception of acids, it's a non-electrolyte. So an ionic, you remember, is a metal with a non-metal, generally speaking. Covalent is when we all have non-metals. Okay, now I should add here, is it ionic or an acid? Because you remember ionic and acids are both electrolytes, okay? That would be H to start something off, okay? H with something else, okay? So there you have it. Electrolytes conduct electricity because they put ions in solution. We're looking for ionic acids and bases to see if it's an electrolyte. Non-electrolytes are going to be other covalent compounds. Don't get mixed up with the alcohol, okay? If it ends in hydroxide, you've got to look and see, is it with a metal like sodium, or is it with carbons and hydrogens? Then it's just going to be covalent. So there you have it.